Greetings to everyone. So today we are going to discuss about the topic of effect of internal pressure on the dimensions of a thin cylindrical shell. Okay, in the thin cylinders topic, we are going to discuss about the effect of internal pressure on the dimension. Okay, so here in the dimension is nothing but the change in length, change in diameter, and the volumetric strain. Okay, now so the change in length and change in diameter is nothing but circumferential strain and longitudinal strain. Okay, so now we are going to discuss about the derivation, then after we are moving to the problem. So let us go to the topic now. Effect of internal pressure on the dimension, on the dimensions of a thin cylindrical shell. So first of all, when a cylinder having fluid means it is subjected to internal pressure. Okay, so because of that internal pressure, we can get two types of stresses. One is hoop stress along the longitudinal section, and longitudinal stress along the circumferential section. Okay, so that we are going to discuss. So when a fluid having internal pressure, small p, is stored in a thin cylinder, cylindrical shell. Okay, due to internal pressure, due to internal pressure, the stresses will develop will develop at any point of the material, at any point of the material. First one, that is circumferential stress. Circumferential stress sigma 1 acting on the longitudinal section. Second one, longitudinal stress sigma 2 acting on the circumferential section or cross section. Okay, so along with this we can have another one, that is principal stress, which is going to acting on the principal plane. Okay, so these stresses are principal stresses, as they are acting on principal plane. Okay, the stress in the third principal plane. Okay, the stress in the third principal plane is zero. With respect to the thickness. Okay, as thickness of the cylinder is very small. Is very small. Okay, so now we are going to calculate those values. Okay, now with respect to the strains. Okay, since because of the small value we are going to neglect it. Okay, now let us consider some terminologies. Small p is equal to internal fluid pressure. Second one is L is equal to length of the cylinder. Then D is equal to diameter of the cylinder. Okay, then T is equal to thickness of wall. Thickness of wall of the cylinder. E is equal to Young's modulus of the material. Young's modulus of the material. Then sigma 1 is equal to hoop stress or circumferential stress. Then sigma 2 is equal to longitudinal stress. Then next mu is equal to Poisson's ratio. Then del D is nothing but change in diameter due to stresses. Change in diameter due to stresses. Due to stresses in the material. Similarly, del L is equal to change in length due to stresses in the material. Okay, and del V, which is nothing but volumetric strain or change in volume. Okay, now let us move on to the concern how to calculate these three values, that is change in length, change in diameter and change in volume. So this one we have to calculate now. So first of all, we all know that the value of sigma 1 and sigma 2. So sigma 1 is equal to PD divided by 2T, and sigma 2 is equal to, that is circumferential stress and longitudinal stress, PD divided by 4 times of T. Okay. Now let us consider E1 is equal to circumferential strain. Circumferential strain. And E2 is equal to longitudinal strain. Okay. So now the circumferential strain. So strain is nothing but with the help of formula. Okay, that is E1 is equal to sigma 1 divided by Young's modulus minus Poisson ratio is multiplied with the longitudinal strain divided by Young's modulus E. Okay. Now we are going to substitute the value for sigma 1 and sigma 2 in this equation. Whereas sigma 1 is equal to PD divided by 2T into E minus mu into PD divided by 4T into E. So here the common terms are P, D, 2T and E. Okay. So if I'm going to take these things outside, so 1 minus mu by 2 is the formula for E1. That is circumferential strain. Okay. Next, we should move on to the longitudinal strain. The longitudinal strain, that is E2. So here the formula is going to change as sigma 2 divided by E minus mu into sigma 1 divided by E. Okay. Now substitute the values of sigma 2 and sigma 1 in this equation. So PD divided by 4 times of T into E minus mu into PD divided by 2 times of thickness into E. So here I am going to take the common terms PD divided by 2TE. So if I am going to take this one as outside, here the remaining term is 1 by 2 minus mu. So this is the longitudinal strain formula. Okay. Next we should move on to the formula, that is the circumferential strain is also given. The circumferential strain is also given as. So normally we are going to write the strain is equal to, that is with respect to its, okay na, change in length. This is circumferential strain, so with respect to cross section. Okay, so change in dia divided by original dia, this is the common formula. Okay, so change in dia we are going to denote by the letter delta D. Okay, and original dia is D. Okay, now whatever we have calculated, that is circumferential strain we have calculated, which is nothing but this value is equal to, we have given in the equation number 1, that is E1. So E1 is equal to del D by small d. Okay, so circumferential strain E1 is equal to change in dia divided by original dia. So change in dia we are going to denote by del D, and original dia will be denoted by small d. Okay, now the formula is PD divided by 2 times of T into E is equal to, from equation number 1, 1 minus mu by 2. 1 minus mu divided by 2 is equal to del D divided by D. So from this, the change in diameter del D is equal to, so the change in diameter del D is equal to, del D is equal to, so D is going to be here. So pressure intensity P D squared divided by 2 times of E multiplied with 1 minus mu divided by 2. So this is the formula for change in diameter. So if I'm going to take this one as equation number 2 and this is equation number 3 for change in diameter. Similarly, I have to calculate the change in length. Okay. So change in length, that is the longitudinal strain. The longitudinal strain E2. So E2 is equal to change in length. I'm going to take as del L divided by original length. This is nothing but L. So if I'm going to keep, what about the E2 value? So from equation number 2, the E is equal to E2 is equal to P into D into 2TE multiplied with half minus mu. So 1 by 2 minus mu. So which is equal to del L by L. So from this change in length, del L is equal to PdL divided by 2TE into half minus mu. So this is the equation is used to calculate the change in length, equation number 4. Okay. Next, I have to go for volumetric strain. Okay. So volumetric strain is nothing but the change in volume by original volume. Okay. So volumetric strain is equal to change in volume divided by original volume. Okay. So here I'm going to consider the section is cylindrical. Okay. So that the change in volume and original volume, I have to calculate the values, that is by using the formula. Okay. So the change in volume is equal to del V and original volume we are going to denote as V. So original volume by 4 into d squared into length. Okay. The change in volume we are going to denote change in volume del V is equal to final volume, that is after the dimension changes, that is the length and cross sectional details changes. Okay now, so those changes is called final volume. If I'm going to consider those changes, okay, the final volume minus the original volume will gives the value of change in volume. Okay, so the final volume I'm going to write, that is uh, final volume, I'm going to write it as final area of cross section, final area of cross section multiplied with final length. Okay, so here the final cross section is nothing but by 4 into, if I'm going to put small d squared, then it becomes original area. So along with that, the change in diameter, if I'm going to mention, then it becomes a final area. Okay, so d squared plus del d. Okay, so if I'm going to consider this, it becomes the final volume of the cross section. Okay, so d plus d del d the whole square multiplied with change in length. So change in length is nothing but original length plus change in length, sorry, final length is nothing but original length multiply plus change in length. Okay, so this I'm going to, now this time d plus del d the whole square is nothing but the formula like a squared, sorry, a plus b the whole square. So if a plus b squared is nothing but a squared plus b squared plus 2ab. Okay. So like that I'm going to expand. Okay, so pi by 4 into a squared plus b squared plus 2 into ab multiplied with L plus del L. So if I have to multiply this term with respect to L. Okay, so pi by 4 I'm going to take at outside as a common term. Now these terms going to multiplied with L and then after multiplied with del L. Okay, so d squared L plus del d squared L plus 2 d del d L plus d squared del L plus del d squared del L squared plus 2 into d into del d into del L. So now I have to remove some terminologies, which is nothing but that change in diameter and change in length. When comparing with its original length and original dia, it is negligible. Okay, so those terms I am going to remove from here. Okay, so those terms are, so del d squared L I am going to remove, and del L del d squared. Okay, now similarly del L del d squared. So this also I'm going to remove. This also I'm going to remove, and this one also I'm going to remove. Okay. Now the remaining terminologies. Now the remaining terminologies. Since when comparing with L, comma D, the del L and del D value are less. Values are very less. That's why we are going to remove that. Okay, so if I'm going to remove those things, finally I can get pi by 4 into d squared L plus 2d into L into del d plus del L d square. Okay, so this is our final volume. Okay, therefore change in volume. So change in volume is nothing but del V. Okay, so the original volume, sorry, final volume minus original volume. Okay, final volume is nothing but pi by 4 into d squared L plus 2 into d into L into del d plus del L d squared. Okay, along with that minus original volume. So original volume is nothing but pi by 4 into d squared into L. Okay, now here if I'm going to modify, or this pi by 4 if I'm going to multiply d squared L plus pi by 4 into 2dl into del d plus pi by 4 into del L d squared minus pi by 4 into d squared L. So these two term becomes get cancelled. Okay, so the remaining term is pi by 4 into 2dl del d plus del L d squared. So this is the change in volume. So now I have to go for volumetric strain. So volumetric strain is equal to volumetric strain is equal to change in volume by original volume. So here the change in volume is nothing but pi by 4 into del 2dl del d. So 2dl del d plus del l d square, del l d square divided by original volume pi by 4 into d squared into l. So if I'm going to split up into those two options, okay now, that is pi by 4 into 2 dl del d plus pi by 4 into del l into d squared divided by, sorry, divided by pi by 4 into d squared l, pi by 4 into d squared l. So what are the common terminologies is going to cancel. So this will get cancelled. So here L is going to get cancelled. Instead of D, here on D is going to cancel. So the remaining term here 2 into del D divided by D. Okay. Plus here pi by 4 get cancelled, the D squared by and D squared get cancelled. So remaining term del L by L. So this is our change in volume by original volume. That is volumetric strain. Sorry, change in volume by original volume. So this is the value. Okay. Now, if I am going to consider, okay, that is this del D by D is nothing but E1. Del D by D is nothing but E1 and del L by L is nothing but E2. So that I am going to incorporate here. So del V by V is equal to 2 into E1 plus E2. So this is the another equation which is used to find out the volumetric strain. Now the substituting this E1 and E2 value, okay, so that we can calculate the change in volume. So instead of E1 and E2, I'm going to substitute this. Okay. So equation number 5 and 6. Equation number 5 and 6. So if I'm going to substitute E1 and E2 value in equation 6, then equation 6 becomes del V by V is equal to 2 into E1. So E1 is nothing but PD by 2TE into 1 minus mu divided by 2 plus E2 value. So E2 is nothing but PD divided by 2TE into half minus mu. So if I'm going to simplifying this, so PD divided by 2TE is the common term everywhere. So now I'm going to take it outside. So if I'm going to multiply this 2 minus 2 into mu divided by 2. Okay, and here this thing come outside. So it becomes plus half minus mu. Okay, then it becomes PD divided by 2 times of E into, so get cancelled, minus mu becomes 2 mu. Okay, and here if I'm going to take LCM, so if I'm going to take LCM 2, then it becomes 2 into 2 4 plus 1 minus, here 1 mu and here 1 mu, so 2 mu. So it becomes PD divided by 2 times of E into 5 by 2 minus 2 mu. So okay, so this is the formula for change in volume by volume if I am going to simplify with respect to this. And in other hand, we can say we have another relationship, that is del V by V is equal to 2 times of E1 plus E2. So from this change in volume, del V is equal to volume, original volume multiplied with 2 into E1 plus E2. So E1 is nothing but circumferential strain and E2 is nothing but longitudinal strain. So these are the formula we are going to use to calculate the change in volume, longitudinal strain and circumferential strain and volumetric strain. Okay. So next we will discuss about the problems. Thank you.